United States plans to send a manned mission to Mars by 2030. And those Mars astronauts are going to need a brand new spacesuit. The one they use today hasn't changed much since that day in 1969 when Neil Armstrong set foot on the moon.
It's one small step for man, one giant leap for mankind.
Okay, so I'm not on the moon. For starters, there's no wind on the moon. But this is the sort of outfit the astronauts wore on the moon. In fact, it's the bog standard NASA spacesuit. It's been to the moon, goes up in the shuttle, but it's not going to cut it on Mars. The old suits are gas pressurised. They fit around the body like a big balloon, which means they use a lot of oxygen. Mars's stronger gravity means they'll weigh twice as much as they did on the moon. They're also not built for fiddly work. The journey to the Red Planet would take about 6 months. Once on Mars, the crew would have to spend at least a year and a half there before the Earth was close enough for them to return. In other words, they'd be away for more than 2 years. Comfort, flexibility and ease of use of their spacesuits is a real issue. A decade ago, some NASA renegades, frustrated by the then official lack of interest in a manned mission to the Red Planet, set up a Mars research station out here in the desert. I'm here to meet Australian systems engineer James Waldy. He's working on the new spacesuit called the MarsSkin.
Graham.
Commander James.
Welcome to MDRS 39.
Thank you.
Please come in.
Graham Phillips reporting for duty. What's the real deal? This tin can is called the HAB, a prototype of a Mars station.
Well, Graham, here we are in the living quarters of the HAB.
Okay.
You can see around here, here's the workstations, and the other members of the crew are busy working on there with communications and other work.
Hey, how are you? Hey, welcome to Mars.
Yeah, thank you. So this is the conventional spacesuit.
That's right.
Looks a bit dirty.
Yeah, it is a bit dirty. It's been used quite a bit, but these have proven to be extremely durable.
James's suit is something you'd find on the space shuttle today. And I've got my very own MarsSkin to try on for size. Okay, there you go. Now my suit, as you can see, completely different. And the key to this suit is this inner lining here. It's skin tight, it's elasticized, so it's squeezing on my body, providing pressure. So the spacesuit doesn't have to be pressurized. It doesn't have to be filled with oxygen. All I do is wear this sort of loose fitting outer layer, which protects against radiation and space dust. And it is so much more comfortable, very flexible. On Earth, our bodies are subject to a pressure of 10 tonnes per square metre. We need it to force air into our lungs and keep gases in our bloodstream. But outer space has no atmosphere, and gas-filled suits provide the pressure instead. Rather than using gas to pressurise the body, the MarsSkin will use electroactive polymers, elastic fibres still under development, to squeeze the body. Okay. Is that for you or for me?
This is for me.
All right.
You can hold that up.
There's a bit of weight in this.
Yep.
You have to carry a lot of oxygen to keep the old suits pressurised. The MarsSkin only pumps oxygen into the helmet, so far less oxygen will be needed on a Mars walk. Yeah, right. Gee, that's nice and light as well.
It should be about half the mass of mine.
Once in the airlock, an astronaut would switch his still loose suit into shrink-wrap mode. A change in electric current through the fabric of the suit alters the shape of the polymers threaded through the fabric, causing the suit to hug him tightly. He's now ready for the surface of Mars. Here we are. The giant leap forward in suit design is the MarsSkin's flexibility.
Yeah, it's good.
Can you bend over?
Bend over, touch my toes. No, I can't do that anyway, even without the suit on, but very flexible. How's yours?
No, I can't bend over.
The Mars atmosphere is mostly carbon dioxide and very thin, only 1% of our own. So a tough outer layer over the elasticized suit would be needed for protection from micrometeorites and radiation.
Let's jump on these scooters.
Let's go.
All right.
If James's old gas-filled suit tore on Mars, he would be dead in minutes. Loss of pressure takes oxygen out of the blood in the lungs. In seconds, his unoxygenated blood would reach his brain. With my MarsSkin, though, a tear on the body would only affect skin at the tear. Damage would be minor, and the rest of the suit would retain pressure. Another disadvantage of gas suits is they actually leak. A suit can lose 50 litres of oxygen during an 8-hour spacewalk. A Mars mission using the old suits would mean taking thousands of extra litres of oxygen just to allow for suit leaks. Now, it's early days yet. Obviously, this suit needs a lot more development. Indeed, the materials needed to make it work won't even appear for at least another 5 years. But if James has his way, some version of this suit will be what those first astronauts wear when they go to Mars.